One of the most common questions we get about Android performance is about using enums in your code. This question pops up literally everywhere on Stack Overflow, Q&A after our talks, and even during casual lunches at the local food court. Ugh. Anyhow, my name is Colt McCandless, and enums in your Android apps are both tricky and not so tricky, which is why there's some confusion. But a little history here. So back in 2009, there was a web page on developers.android.com that said to avoid using enums for performance reasons. But then it mysteriously disappeared for a while without really much explanation. And then, of course, it came back later, but in a much smaller state. So what's the story here? Well, the truth is a little bit nuanced and has everything to do with the difference between performance and memory bloat. See, when your app is loaded, Android will set aside a section of system memory just for your app. And in order for your app to run, all of the DEX code for it is loaded into that subspace. But of course, this is ultimately shared with the rest of the heap for any runtime allocations that your app will make. Thankfully, though, this doesn't contend with your runtime allocations. However, it does put more pressure on the system memory, which, of course, when memory gets low, could cause your app to get terminated to free up space. So with that in mind, let's take a look at the effect of enums on your application. Let's say we have a small base app here whose entire DEX footprint is 2556 bytes. To this, we add some integers that represent states that can be used and returned for our system. After recompilation, the final DEX size is 2680 bytes, meaning that these integers, in terms of code size, have added an extra 124 bytes to our base executable. Now, for comparison, let's take the same base application, but implement it with enums instead of integers. The result here is a DEX file of 4188 bytes. So, adding a single enum to this code has added an extra 1632 bytes to the final DEX size, or for those of you who are super fancy with math, about 13x more memory than the int version. This, of course, bloats your DEX file, which eats away at your heap space. If this isn't bad enough, though, there's also the runtime memory overhead to be concerned with as well. In general, each enum value declaration will cost you about 20 plus bytes. Of course, plus there's the object array needed to keep track of the enum values, so that's another 12 bytes for that header as well. Well, it's 16 on Dalvik, by the way. Anyhow, this extra overhead is taken by each enum declared in your code, meaning that the more enums used by your app, the more space that's going to be eaten up. And this whole thing can get out of hand easier than you might think. For example, if enums are widely used across your application, or if they're inside of a library that's used by many applications on the device. All of those small pieces of overhead quickly add up to a substantial amount. And the worst part is that you don't really know that enums are causing a problem until they're already infecting your code base. And by that point, trying to fix it is really a horrible process. Think of it this way. Enums are kind of like gremlins, right? One or two by themselves, not really a big deal. You can take them out with like a rolled up newspaper or a baseball bat or like a flamethrower if you got one of those laying around, right? But when you get a whole bunch of them together, trouble really happens there, and you really wish you had the flamethrower. That's why the core platform team, the folks who actually write the Android code, have a strong recommendation to avoid using enums in any part of the code they write. This allows them to be proactive about the potential problems here rather than being reactive. So with that in mind, here's a couple things that you should consider to address the problem. Firstly, if you're using ints for values instead of enums, you can add the @intDef annotation to them, which will give your code built-time safety when lint errors are enabled, while still retaining the size and performance benefits of using int variables. Basically, this allows you to get the best of both worlds. And secondly, if your code is set up the right way, ProGuard can, in many situations, optimize enums to int values on your behalf, so you really don't need to think about it or do any work, which is one of the few places that you might get performance wins for free. See, most of the time you really have to fight for it. Which is why you should check out the rest of the Android performance patterns videos and stop by to ask some questions at our Google Plus community as well, because you're not alone. So keep calm, profile your... Oh my God! Oh my gosh!